you must size the electrical system to the transformer. The transformer's capacity is the limiting factor. In this scenario, the transformer has a capacity of 112.5 kVA. This means it can only safely supply up to 112.5 kVA of power to the load. If the load exceeds 112.5 kVA, the transformer risks overheating and potentially failing. The load in this instance is 80 kVA, which is less than the transformer's capacity. However, it's vital to consider that the load is a standalone machine tool. This type of equipment is often large and powerful and might exceed 112.5 kVA under certain operating conditions or during peak demand. Because of this potential for exceeding the capacity of the transformer, it is crucial to size the electrical system based on the transformer specifications regardless of the load requirement. This ensures that the transformer isn't overloaded, maintaining a safe and reliable system. If the electrical system was sized to the load, the transformer would be undersized. An undersized transformer is subjected to overload conditions. Overloading can cause premature failure of the transformer, damage to the transformer itself, and potentially damage the load connected to it. Moreover, it creates a significant safety hazard. Based on the transformer's size, you would require a 175 amps primary breaker and number 2/0 primary conductors along with a 400 amps disconnect and number 750 kc mil secondary conductors. Sizing to the load would entail a 125 amps primary breaker using number 2 primary conductors along with a 400 amps disconnect with 300 amps fuses and number 4/0 secondary conductors. Firstly, the transformer's kilovolt-ampere rating determines its maximum output capacity. Attempting to draw more power than it's designed for leads to overheating, insulation breakdown, and ultimately failure. Secondly, machine tools often exhibit significant inrush currents during startup or periods of heavy operation. These transient demands can far exceed the nameplate rating of the tool, placing undue stress on an undersized transformer. Thirdly, safety codes and regulations such as the National Electrical Code, or NEC, prioritize the protection of electrical equipment. Proper sizing ensures that the transformer operates within its design limits, minimizing the risk of fire or electrical shock. Fourthly, an undersized transformer will experience voltage drops under heavy load. This can affect the performance of the machine tool, leading to malfunctions, reduced efficiency, or even damage. Fifthly, replacing a failed transformer is costly, involving not only the price of the new unit but also downtime and labor expenses. Proper sizing minimizes the risk of such costly disruptions. To reiterate, always size the electrical system to the transformer's capacity. This ensures safe, reliable, and efficient operation.